In this video, we're going to look at how signs affect inequalities. So let's start with our easiest scenario, two positive numbers, A and B. We can see that A is less than B because it's to the left of B on the number line. And we can give those numbers. Let's say A is a value of 2, B is more than A, so let's say B is 6. 6 is more than 2, B is more than A is less than B, 2 is less than 6. All right. Now, we could keep B at 6 and slide A over here to the negative side. And let's say here, you know what, instead of A and B, let's make these different values here, C and D, where here C is negative 2. Right? Negative 2 is less than 6. That's fine. C is still less than D. And we can look at positive 2 and negative 6. Right? 6 is further away from 0, but it's still less than 2, because 6 below 0 is less than 2 above 0. Right? So C is less than D, is less than F. And we can even consider another scenario here where both of them are negative. So let's call those G and H, negative 6, negative 2. In every instance, sort of by definition, the number on the left is less than the number on the right. That's how less than and greater than work, right? 6 feet below sea level is further down than only 2 feet below sea level, right? All of these instances, I hope, are pretty straightforward. What we want to look at now is what happens if we get the reverse. If we multiply all of this by a negative 1, right? If we multiply the left by something and multiply the right by that same thing, we're good. So the opposite of A is negative A. So that's bumping us over 0. The opposite of A is negative A. The opposite of 2 is negative 2. All right. And the opposite of B. The opposite of B goes over here. The opposite of B. It was 6 to the right of 0. Now it's 6 to the left of 0, negative 6. So we have negative 6 and negative 2, when before we had 2 and 6. 2 is less than 6. Negative 2 is not less than negative 6. We actually have the opposite situation. Negative 2 is now greater than negative 6. And that works with all of these inequalities. Right, so C is less than D. That was represented with negative 2 less than 6. Why is it red? Negative 2 less than 6. Let's put all of these number inequalities here. E is less than F, negative 6 is less than 2. G is less than H, negative 6 is less than negative 2. When we come in and change the signs, whether we're saying times negative 1 or divide by negative 1, whether we write it separately for each expression, it's a negative there. Right, however we're indicating that, when we reverse the direction from going from the left to the other direction, from the right to the other direction, our inequality symbol is going to change, right? The opposite of negative 2 is a positive 2. The opposite of 6 is a positive 6. Sorry, the opposite of a positive 6 is a negative 6. Negative 6 here is less than a positive 2 here. Negative 6 is less than this positive 2. The opposite of C is now more than the opposite of D. E is less than F. Negative 6 is less than 2, but the opposite of negative 6 becomes positive 6. Now over here at positive 6. 2 is getting reversed. The opposite of positive 2 is negative 2. So the opposite of F is negative F. This negative F is now less than the negative E. The negative 2 is now less than the 6. I was saying E was less than F, but now the opposite of E is more than the opposite of F. The opposite of E is greater than the opposite of F, right? And it's the same thing here. As soon as I multiply by negative 1, the opposite of that, the opposite of this, the opposite of this, the opposite of this. Negative 6 is less than negative 2, but positive 6 is greater than positive 2. Now we're up here at positive 6. Now we're up here at positive 2, the opposite of H. So what's our main takeaway from all of these pictures, all of these diagrams that maybe looks a little overwhelming? When I just have something less than something else, I don't know if these two letters are positive or negative. I don't know if A is representing a positive value or a negative value. I don't know if B is representing a positive value or a negative value. But I know that once I multiply by negative 1 or divide by negative 1, right? Once I change the sign of this expression, the inequality bumps the other way. This is always true, and we can show that whether A and B are both positive, whether one's positive, the other negative, whether they're positive and negative the other way, or whether they're both negative, it's still the case that the inequality relationship reverses. So when we see a question where the original problem says something like negative x is less than 6, and I'm trying to think, okay, what's going on here? Well, here's 0. Negative x is less than 6, so here's 6. The opposite of x is less than 6. So the opposite of x here, less than 6. The opposite of x here, the opposite of x here, the opposite of x here. Well, if this is the opposite of x, then x has to be bounced over the number line. That's where x was. If this was the opposite of x, I have to bounce that over the number line, and I get over here for the original x. Right? Each time we're bouncing it over 0, well, I can just divide by negative 1, right? The reverse of the opposite of x is actual x. But if I'm reversing this, I'm reversing this as well, and this is now false. Because by reversing it, I must reverse this symbol. Now it's true. Right? Anything above negative 6 is going to work out. Right? Let's pick a number for x. Let's say x is 1,000. The opposite of 1,000 is less than 6, so 1,000 works. Let's say x is 10 billion. The opposite of 10 billion is negative 10 billion. Negative 10 billion is less than 6. All right, that works. All right, so these giant numbers are all working. Let's try negative 1,000. What's the opposite of negative 1,000? The opposite of negative is positive. Positive 1,000. 1,000 is not less than 6. That's not going to work. Let's try negative 10. The opposite of negative 10 is 10. 10 is not less than 6. That doesn't work. Let's try negative 3. The opposite of negative 3 is 3. 3 is less than 6. That works. Here we go. Here's negative 6. Here's negative 3. Right? That works. Let's try a positive 3. The opposite of 3 is negative 3. Negative 3 is less than 6. Definitely. Playing guess and check is going to take a long time to actually zero in on what possibly might work. We're not ever going to be able to guess every single number to see if it works. There are an infinite number of numbers. But we can see, oh, what just happened? We can see from the way we solve equations that the 6 is going to become a negative 6. And then if we're not sure what's going on here, we're not sure if x is on the right or on the left, we can just pick test cases on either side. A number bigger than negative 6 is 0. So I'm wondering, is 0 possibly a solution to the original? The opposite of 0 is 0. 0 is less than 6. Yes. If 0 works, everything else on the same side as 0 is going to work. And just to double check, pick something on the left, negative 10. Negative 10 didn't work, so that's not going to be shaded in. So there's our answer. From negative 6, going on to the right forever, I'm excluding the endpoint. So there's my interval notation. Right, this is not an ordered pair x comma y. This is not an order of operations grouping symbol. There's no operation here. I'm just listing the left endpoint and the right endpoint of my interval. And we can use that for all kinds of problems. So let's look at a more interesting problem, more complicated problem. Let's try, come on, here we go. 3 times x minus 2 minus 1 is less than 2 minus 5x plus 6. All right, so we got parentheses in here. We've got a lot going on here. Well, to solve this, and we are solving, we have a statement here with an inequality symbol in between. We're not just simplifying, we're trying to find out which values of x will make this statement true. But it's the same process as solving an equation. We start by simplifying. I could add 1 to both sides, but this cancels, this isn't going to cancel, and I still have more distributing to do. I could try to divide everything by 3, but that gives me a fraction, that gives me a fraction, this gives me a fraction. Ugh. The best plan here is to distribute 3 times x, distribute 3 times minus 2 minus 6. This 1 is outside of these parentheses, so he just stays there. Now I have some like terms, so I have 3x minus 7. Now I can look at this side. I have a 2 minus 5 times something. So I'm going to think of that as plus the opposite of 5. The opposite of 5 times x is negative 5x. The opposite of 5 times 6, negative 3. Right? I'm distributing the negative and the 5 both to each of these terms. So 2 minus 30, that's negative 28, and the 5x is still there, right? Can't combine these, they're not like terms. Now this is as simplified as I can get it, this is as simplified as I can get it, and now I have a choice. Do I add 5x to both sides? Do I subtract 3x from both sides? Either way will work. So let's just pick one. It's kind of nice for our inequality symbols to start with x is, so I'm going to add 5x to both sides there. 3x plus 5x is 8x. Now that my x's are on the left, I'm going to add 7 to both sides. I should have switched colors, I'm sorry. Negative plus, those are going opposite directions, so I get the difference, which is 21. This is a negative number, but I didn't multiply by a negative number. Now I'm going to cancel the 8, so I divide both sides by 8. I get x is less than, 21 is 3 times 7, 8 is 2 times 2 times 2, nothing cancels here. Negative 21 eighths. And so I can graph that. Let's see here, so here's, it's always nice to put 0 on there, but just to emphasize I'm at a negative. X is less than that, so I'm shading in on this side. And I can either use the open circle or the parenthesis here. The parenthesis helps me easily see I'm going from negative infinity up to negative 21 eighths, but not including it. Or it can use the fancy set notation, all x such that this condition is met. And I think that's preferred in the textbook we're using right now, but they're equivalent statements. I could have put an open circle here. Notice I didn't convert that to 2 and 5/8 negative. There's no need to write this as a mixed number. There's no need to write it as a decimal. It's a reduced fraction. That's good enough. Now let's back up just a little bit. I said we had a choice. We could add 5x to both sides, or we could subtract 3x from both sides. So let's see what happens if we do it that way. If instead of adding 5x, I subtract 3x, 3x minus 3x is 0. 0 minus 7, that gives me negative 7. Negative 28 is just hanging out there. Negative 5 minus 3, both negative. There's minus 8x. So I have my x's on the right side. That means I want to get rid of the 28. It's negative, so I'm going to add 28. Negative 7 plus 28 going opposite directions, so I find the difference, which is 21. My positive was larger than my negative, so it's positive 21. It's just 28 minus 7 is 21. And this negative is still with the 8x. So now I will divide by negative 8. Positive divided by a negative, that makes the whole thing negative. Negative 8 cancels with negative 8, giving me an x. But because I reversed the sign, because I divided or multiplied by a negative, this has to swap. So I see that x is on the less than side compared to the 21 eighths. Right? If I read this left to right, I'll say negative 21 eighths is greater than x. But if I'm asking for the solution, what values of x make this true, x is less than this number. So for our final answer, we definitely want to write it. X is less than negative 21 eighths. And that gives us the same two solutions, right? These are the same solution. A lot of people get tripped up by that reversing the signs business, so you could prioritize always getting your x term to be positive, whether that's on the left or the right. A lot of people get tripped up by reading the inequality backwards, starting on the right side if your x happens to be on the right side. So some people like to prioritize always getting x on the left, whether it's positive or negative, and then reversing the sign as needed. Here we didn't have to reverse the sign because I never multiplied or divided by a negative number. Adding or subtracting doesn't reverse the sign. That's just shifting everything, but they stay in the same relationship to each other. It's when we multiply or divide by a negative that they get reversed as to which one's greater, which one's less. Right? So there's our example of how to solve inequalities. Same process as equations, just watch out for that reversing the sign and recognize that at the end, we don't just have a single number. The solution is not negative 21/8. We have an infinite number of solutions that are bounded by, in this case, negative 21/8.